Welcome back to the tutorial course on Android app development. In this section, we will discuss the various lifecycle methods of an Android application. An application does not control its own lifetime. Instead, the application lifetime is determined by the system through a combination of the parts of the application. For example, the system may determine some of the following conditions. The system checks whether the app is running. The system checks the overall memory available in the system. In an ideal scenario, the Android application that a user starts remains in the memory. Because the applications are residing in the memory, they run faster. However, because of limited memory available on the Android system, it is allowed to terminate the running processes to save memory. It's important that the Android application developers understand the importance of different application components, specifically activity, service, and broadcast receiver, which impact the lifetime of an application's process. It is also important to understand that if these components are not correctly used, the system can kill the application process when it requires more memory. On the next slide, we will continue reviewing the application process. In a real-life scenario, when you install an Android application on an Android device, the system allocates a maximum permitted memory to the application. While the application is running, it is possible that the application exceeds the permitted memory limit. In such a case, the system will kill the application depending on the priority assigned. Consider the following priority order of an application: foreground process, visible process, service process, background process, empty process. In case of low memory, the Android system will first kill the applications with the least priority process and increase the remaining memory available for other applications to enhance the system performance. The following are the application lifecycle methods: on create, on low memory, on trim memory, on terminate, on configuration changed. Let's consider each method in detail in the next few slides. We will first learn the onCreate method. The onCreate method is called before the first component of the application starts. This method is called only once over the lifetime of an application. Open Android Studio. In this example, override is added on the onCreate method inside the application class. Let's put a log inside the onCreate method to track the event. The onLow memory method is called by the system when it's running low on memory. When we call the onLow memory method, we need to reduce the memory by removing the unwanted resources, if any. The unwanted resources can be in the form of cache and others. We need to delete them from inside the application for the memory to be released. We will now add override on the onLow memory method in this application class. Let's put a log inside the onLow memory method to track that event. Note that we will not be able to see this log immediately because it will be called only when the system is running low on memory. Now let's learn about the onTrim memory method. The onTrim memory method is called when the Android system requests the application to clean up its memory. For example, if an application goes to background, the onTrim memory method is invoked. The application's priority is lowered and the system invokes the onTrim memory to trim the unwanted memory. We will now add override on the onTrim memory method in the application class. Let's put a log inside the onTrim memory method to track the event. We will now learn about the onTerminate method. The Android system uses the onTerminate method only for the purpose of testing and not for production. We do not control this method. We will now add override on the onTerminate method in this application class. Let's put a log inside the onTerminate method to track that event. We will now discuss the onConfigurationChange method in the next slide. The onConfigurationChange method is called when the Android system configuration changes. For example, assume that we change the device orientation inside an activity. As a result, the onConfigurationChange method inside that activity class is called. Similarly, if we change the device language, the onConfigurationChange method will be invoked, and the user will be notified that the device configuration has changed. Let's see how this can be done. We will first override the onConfigurationChange method inside the application class. Using the Application Lifecycle methods, the Android OS notifies the user of the different status of an application. Finally, we will run the application and see the log events. The application element contains sub-elements that declare the components and attributes of the application. If we create an application class, we need to specify the name under the application Android:name attribute. We will run the application and see the log events. The onCreate method is called before the first component of the application starts. This method is called only once over the lifetime of an application. Then, we will invoke the onTrimMemory method. For example, if an application goes to background, the onTrimMemory method is invoked. The application's priority is lowered, and the system invokes the onTrimMemory to trim the unwanted memory. Using the Application Lifecycle methods, the Android OS notifies the user of the different status of an application. This brings us to the end of our discussion on the lifecycle methods of an Android application.